Let's use transformations to graph a function. And so I'll work through this in the course of an example. Suppose you're asked to use transformations to graph the function y equals negative the square root of x plus 2 all minus 3. And we want to use that information to give the domain and the range. So the first step is to identify the parent function. So there's a list of functions that you need to know the properties of and you need to know the graphs of. And these are basic functions like y equals x or x squared or x cubed, y equals absolute value x, or y equals square root x. In this example, the parent function is y equals square root x. So this is what the graph looks like. I like to identify a few special points that we'll track as we move through this example. So the first thing to look at is what happens before the parent function is applied. So we're going to trace through our input x and see what happens before we take the square root. These are going to yield horizontal changes or horizontal transformations of the graph. So if you notice, the first thing that happens to x is it gets 2 added to it. So there's a plus 2 on the x. This is going to yield a shift left of 2 units. And that'll give us the graph of y equals the square root of x plus 2. So we're going to try to shift this graph left by 2 units. I like to do this by taking a look at what happens specifically to the points. So the original point 0, 0 on the graph, when it's shifted left by 2 units, goes to minus 2, 0. The point 1, 1 shifted left, so I'm going to subtract 2 from the x-coordinate, becomes a minus 1, 1. And then I do that to the whole graph. And so it's going to go through these 2 points that we marked. And that's it for what happens before the parent function is applied. And now we want to see what happens after. So things that happen after the parent function is applied yield vertical changes. So these are going to be vertical transformations of the graph. And so I'm looking now to see the first thing that happens after I apply the square root. And there's a multiplication by minus 1. There's a scaling by minus 1. That yields a reflection across the x-axis to give us the graph of y equals minus the square root of x plus 2. So that's going to flip this graph across the x-axis. Again, I like to look to see what happens to our special points. If I take the point minus 2, 0 and reflect it across the x-axis, right, all that's going to do is take the y-coordinate and multiply it by minus 1. Nothing changes because 0 times minus 1 stays 0. And so I get the point minus 2, 0 again. And now for this other point, minus 1, 1, if I scale the y-coordinate by minus 1, I get a minus 1, minus 1. And then I do the whole graph, reflected across the x-axis. Notice that it still goes through the marked points. The next thing that happens is minus 3. So we subtract 3. This is going to yield a shift down by 3 units to give us the graph of y equals negative square root x plus 2 minus 3. We're going to try to shift this whole graph down, but again, I like looking at the special points first. So minus 2, 0, if I subtract 3 from the y-coordinate, becomes minus 2, minus 3. And this point minus 1, minus 1, if I subtract 3 from the y-coordinate, becomes minus 1, minus 4. And now I'm ready to shift the whole graph to give me this. So now let's use this information to try to compute the domain and the range. Right, and so I'm going to do this in 2 different ways. The first way I'm going to look at is if I do the transformations and I'm staring at the graph. Right, so remember, we're trying to compute the domain and the range for this blue graph down here. So for the domain, I'm looking to see what are the x values that are allowable inputs to the graph. And so if I notice, I can go all the way from minus 2 for the x value all the way up to plus infinity. But plus infinity is not a real number, and so we leave it an open interval on that end. So it goes from -2 to infinity, closed on the -2 end because we can input -2 into this function, and open-ended on infinity because infinity is not a real number. And now for the range, I'm looking to see what are the outputs of this function. What are the heights? What are the y values that are output by the function? And I notice I can go from -3 down to -infinity. And in an interval notation, I put the smaller value first. And so this is -3, -infinity, -3. It's closed on the -3 side because I do actually attain the height -3. It's open on the negative infinity side because negative infinity is not a real number. Now let's work on it more algebraically. So suppose you trace through all the steps that we did earlier, in terms of looking at what happens to the parent function before and after the parent function is applied. And we're going to trace what happens to the domain. And so this requires you to know that the domain of the original parent function is 0 to infinity. When you do this shift left by 2 units, all that does is subtract 2 from the x values, and so that's subtracting 2 from all the points in the domain. So 0 minus 2 becomes a -2. Infinity minus 2 is still infinity. And so the domain for this shifted function is -2 to infinity, closed on the -2 side and open on the infinity side. If you recall, everything after that were things that happened after the parent function was applied. And we said that means that the changes that they force on the graph are all vertical changes. So in particular, any change after the parent function is applied has no effect on the domain. And so the domain here is -2 to infinity. And now let's take a look at the range. So the original range for the parent function is 0 to infinity. The first thing we did was a +2 on the x, but that was a horizontal change, so it doesn't affect the range. Next, we had this reflection across the y-axis. And so now reflection across the y-axis multiplies all the y values, all the heights, by -1. And so now the new range goes from 0 down to -infinity. And in interval notation, we put the smaller values to the left. And so this is -infinity to 0, open on the -infinity side, and closed on 0. Next, we shift down by 3 units. And so we're going to subtract 3 from all the y values. And so 0 minus 3 is -3, and -infinity minus 3 is still -infinity. And so I get that the range is -infinity to -3, closed on the -3 side, open on the -infinity side. Thanks.